Hello and good day, Algebra. We are covering CO46, adding and subtracting polynomials. And really, your success in this objective goes back to your understanding of elimination in CO42, which is where we got the ox and the oi. We got the coefficients to be the same. This is slightly different, but it really just kind of goes back to that concept there. So your 3 steps in adding and subtracting polynomial expressions. First of all, number 1, we need to write each expression.
Can I go sharpen my pencil?
No.
What?
A sharpened pencil should be something that you verify you have, like a half hour ago when you first come in the room. Not right now.
That's a lot to ask for.
So, write each expression in standard form. That's why we covered it yesterday. You know how to do it, and that's how you should start. Okay. Number 2 is the trickiest of the 3 steps. Number 2 is align like terms vertically. Leaving spaces for, what do I want to say? Spaces for solo terms. I'll call it solo terms. And I'll explain what I mean by that when we start working on it. Elliot. Sure.
Water is helpful.
I love it.
And then step 3 is where you actually do your addition or subtraction. Add or subtract, depending on what the situation calls for. Thumbs up. Got that down? Good? Anybody still writing? Okay. All right. Let's do something.
Yes.
First one here, 3x squared plus 5x plus 9 plus 8x squared plus 12x plus 1. Those parentheses aren't really necessary, but they're there to kind of define each expression. Our first expression is 3x squared plus 5x plus 9. Our second one is 8x squared plus 12x plus 1. Folks, side comments and conversations. No. So what we want to do is we want to write them each in standard form, which they are. So step 1, done. Okay. And then we want to align terms like terms vertically. So our 3x squared plus 5x plus 9. And then below the 3x squared, we're going to put the what? 8x squared. Below the 5x, we're going to put the what? 12x. And below the 9, we're going to put the what?
1.
The 1. Okay. Now, I said this was very similar to elimination, where we added and subtracted expressions to solve for a variable. The difference here is we don't need these coefficients to be the same, because we're not solving for x. There's no equal sign. We're not interested in what x is. We just want to combine the like terms in these expressions. So we just go vertically. 3x squared, we get 8 more. What do we have? 11 x squared.
What if it's a 3 and a 2? Then you could.
That's why we align the like terms, right? If this was x cubed and x squared, then we would not be able to add them. Correct. Okay. 5x plus 12x, 17x, and 9 plus 1, 10, and we're done.
That's it.
Yeah. That's it.
Alrighty.
Okay. That's it. The next one, 17x minus 4 plus 9x plus 10. They're already in standard form for us, so we'll go ahead and align our like terms vertically. 17x minus 4, and then we have that 9x, which will be below the 17x, and the positive 10, which goes below the negative 4. Again, we're adding them, as what our operation tells us to do here. So 17x plus 9x is 26x. Negative 4 plus 10 is positive 6. And we're done. Okay. Third one. We introduce subtraction here. 9x cubed plus 4, no need to reorder anything there. 15x cubed plus 3, no need to reorder anything there. But we are subtracting. So we have to make sure we go back to that subtraction sign every single time here. 9x cubed minus 15x cubed gives us negative 6x cubed.
Oh, yeah.
Plus 1, right? 4 minus positive 3. It's not 4 plus 3. 4 minus positive 3 is a positive 1. Okay? One thing I want to point out here is notice that our exponent doesn't change when we add or subtract. Oftentimes, a wrong answer here would be like 11x to the 4th. Okay? No. 3x squared. Whatever x squared is, whatever value that is, we have 3 of them. We're getting 8 more. Total, we have 11. So this exponent does not change. Right? X, all power of 1 there does not change there either. You know, cube. Okay? Last one on this page, 13x minus 10 and negative 5x squared plus 2. 13x minus 10, you can write that out. No need to reorder that. But here's where step 2 is important. Can that 5x squared go beneath the 13x?
No.
No. So it's a solo term. Right? As the 13x's, there's nothing to combine it with. So that 5x squared has got to go out in front where an x squared term would go if we had it in the top expression. And it's not a bad idea to just kind of add in here 0x squared more as a placeholder. Just remind ourselves that in that top expression, we do not have any x squared term. Okay? And then that positive 2 goes beneath the negative 10, right? So if you want to write plus 0x here, just more as a placeholder, to remind yourself you don't have any x's in that second expression, and then the positive 2. Okay? And here's why writing that 0x squared in particular is very helpful, because we are subtracting here. And so you do have to think about this as 0x squared minus 5x squared. You can't just bring down the 5x squared because there's nothing to combine it with. It is 0 minus 5, which would make it negative 5. That oftentimes gets missed. Okay? It's more easily taught if you do right that there's no x squares in that top expression. Then you see 0 minus 5, negative 5. Right? 13x minus 0x is still 13x. Nothing is taken away. And negative 10 minus positive 2.
Negative 12.
Negative 12. Yep. So negative 5x squared plus 13x minus 12 is our final answer. So here's where step 2 kind of comes into play here with those solo terms, the terms you can't combine anything with. You have to keep them separate. And then it's a good idea to write that 0x squared to 0x or whatever it is. Okay. Questions on this? All right. Looking at the second page, which is going to be your homework for tomorrow. Any that look particularly worth our time doing together? There are 6 of them
Last 2.
to pick from. Claire,
That's the last one.
the last one. Why do I even bother asking? We always go to the last one. Okay. So the last one is not written in standard form, and so we do have to reorder it a little bit. Okay. So look at that first expression. I see I've got an x to the 5th. That's my highest power, so that's going to be put first. Okay. I don't have an x to the 4th, but I do in my second expression. So I'm going to put 0x to the 4th as a placeholder, just to remind myself. I don't have an x cubed term in my first expression, but I do in my second one, so I need to leave a place for it. And so I'm going to put 0x cubed there also. Right? I do have an x squared term. I do have an x term. And I do have a constant. Okay. My second expression, I do not have an x to the 5th term. So I'm going to just note that by saying 0x to the 5th here. I do have an x to the 4th term, which will go below my 0x to the 4th that I wrote there. I do have an x cubed term. And then no, oh, I do have an x squared term, 3x squared, there it is. I do have an x term, and I do have a constant. And this is all being subtracted. So standard form, align like terms vertically, leaving spaces for those solo terms, ones that can't be combined. And then now we add or subtract vertically. So 15x to the fifth minus 0x to the fifth is still 15x to the fifth.
Negative 9x to the fourth.
0x to the fourth minus 9x to the fourth is a negative 9x to the fourth. 0x cubed minus negative 8x cubed. Positive 8x cubed. You really got to pay attention to details here. Okay? The details, those signs. Negative 18x squared minus 3x squared. Negative 21x squared. Negative 20x minus negative 20x. 0x. They cancel out. 3 minus 3? 0. Cancel out. So our final answer is right here. That wasn't so bad. Dare I say, maybe even a little fun.
You don't understand.
Okay, fair enough. Yes, sir.
Bottom first one.
Oh, we're doing another one?
Yeah.
All right. Spirit of Christmas. Looking at, I'm gonna kind of erase this first part here, so I got room to write. So sorry if you're still jotting it down. You can always watch the video. Next one, again, not written in standard form. My largest term here's an x cubed, so I'm gonna put that one first. Negative 12x cubed. I do have an x squared term as well, positive 4x squared. I do have an x term, and I don't have a constant. The other expression does, so I'm just going to put a plus 0, just a placeholder, just to remind myself. I have an x cubed in the second expression as well, so put that below my negative 12. Negative 12x squared, negative 3x, and then positive 9. And this time we are adding here, so there we go. Negative 12x cubed plus x cubed.
Negative 11.
Negative 11x cubed. Remember, this does have a coefficient of 1. So negative 12 plus 1 is a negative 11x cubed. 4x squared plus negative 12x squared. Negative 8x squared. 8x plus negative 3x. Positive 5x. And 0 plus 9 is positive 9. One of those objectives that I think might look more intimidating than it actually is, kind of once you understand what's going on here. That's going to become a theme as we go through the unit here. If you flip ahead at what's coming up, look at it like, oh my gosh, this is going to be, whoa, heavy. It's really not if you understand the basics. You know, how do signs interact with each other, standard form, like terms, you know, you've got those foundational skills. It's really just how do I set it up, you know? So, yeah, Max.
On the other question, why is the 8x cubed positive? I thought it would be
Because we were originally subtracting here,
Oh.
and so it was 0 minus negative 8, which turns into 0 plus 8. That's why it's positive. Good question. Anything else? Yeah.
How much time do we have left?
14 minutes.
Can we do one more?
No, you can do the rest of them.
Yeah.
You can do the rest of them.
So the
You
spirit
can
of St. Patrick's Day.
Yeah. What? Okay. All right. The rest of it is homework for tomorrow. No con due tonight,
Let's go.
so no excuses. Let's play the number game again tomorrow, and this time let's be victorious. Sound like a plan?
Yeah.
All right. That's what I meant, folks.
Don't forget to